So today is section 7.5 in pre-calculus, and so this is going to be the last letter in our standard form. We've done 3 of them, and now we're going to bring in the final letter. So this is going to be everything we're going to do related to sine and cosine graphs. So once again, as always, remember the standard form for sine or cosine is y equals, you could have a number a out in front. Just for fun, I'll use cosine this time. So the cosine, and then you have letter B, and then in parentheses you might have x plus or minus some number, and then at the end plus or minus D. And all the ones we've done so far haven't had a parenthesis because there hasn't been a C. And so if there's not a C, let me just show you. If there's no C, then you don't need the parentheses, and so that's why it was just B was right next to the X, okay? But now we're going to talk about what if we do have a C. Okay, so kind of our summary. Remember, A told us about amplitude. And the thing to remember about amplitude is that we called that a vertical stretch. Now, I'm using the word stretch loosely because it might be that it stretches it out, or it might be that it squishes it down. Just giving you an idea. If I have a basic, let's say, cosine function, right, I could stretch it out vertically, or maybe I squish it down to be, much flatter. Okay, that's not a good example, but you got the idea, right? Stretch or a squish. Basically, it's not like we're shifting the entire thing up or down, okay? And then we went, in the order that we did them, then we went to letter D. Remember, letter D represents a vertical shift. Okay? And remember, the difference between a stretch and a shift is that on a shift, you pick up the entire graph and move it up. Remember, on the stretch, the zeros did not change. Okay? And then we brought in letter B. Remember, letter B is what told us about the period. And I will go ahead and write down the formula. Remember, the period is 2 pi over B. And so if we change the period, then we're changing it horizontally. We called that a horizontal stretch. Again, if I change from the period to 2 pi to 4 pi, yeah, you're stretching it out. But if I change from my 2 pi down to 1 pi, it's like you're squishing it up. But I'm not shifting the entire graph. I'm just squishing it up. Okay? So you tell me, if we're on letter C now, look at what we've done. We've done a vertical stretch and a shift. We've done a horizontal stretch. So surely you would know then that letter C is going to represent a horizontal shift. So what if we want to pick up the graph and move the entire thing to the left or right? And there is actually a formal name for this in trig. It's called the phase shift. I don't care if you necessarily use that word as opposed to a horizontal shift, but I wanted you to know that in textbooks, that's what they'll call that. They'll call it the phase shift. Vertical shift doesn't have any other special name, I don't think. I don't know, maybe other teachers smarter than me have a name for it, but I don't know what it is. Okay, so let's look at example 1. Now, you don't have to write out everything. I think it would be helpful to, at a minimum, just kind of give yourself an A, B, C, D, kind of like just as a mental checklist, okay? So I know that A tells me the amplitude, and in this case, the A number out in front is 1. I know that B might adjust the period. In this case, the B number, remember the B is what's out in front of the X, out in front of the parentheses, and if there's not a number, it's an implied 1. And anytime it's 1, so the period is 2 pi over 1, so the period is just 2 pi. The D, remember, out at the end is your vertical shift. In this case, there is no number being added or subtracted out at the end, so there is no vertical shift. It's not going to be shifted up or down. Okay, so the horizontal shift. Now, again, you may or may not remember back when we did parabolas, the number that was inside the parenthesis, remember, moved your parabola left or right. But do you remember that it was the opposite of what you would think? So for letter C, we're going to say the horizontal shift is pi over 2, but because it's a minus, it's pi over 2 to the right. And I hope that makes sense based on all the transformations you did back in Algebra 2 and pre-calculus. So maybe we should write that down up here, since this is specifically about horizontal shift. Maybe we might say moves left or right. But remember, left is if it's a plus, right is if it's a minus. Okay, so this was minus pi over 2, so it's going to be pi over 2 to the right. So again, we're going to do this in two graphs, and here's the way I would suggest you do it. Put the amplitude and period in the first graph, and then we'll bring in both of these in the second graph. Okay, so we know our period is 2 pi. So there's 1 pi and 2 pi. And even though that's the one that, was always our standard, since we're in the habit now, I'm just going to mark that off so I know, hey, one full section of this graph is going to happen in 2 pi. Since this is the sine graph, I know it starts, ends, and halfway at 0. And then halfway between each one of those is where it goes up to its amplitude. So up to 1, down to -1, because the amplitude was 1. So there's my graph that brings in both the period of 2 pi and the amplitude of 1. Okay, and so now I'm going to take every single point, and in this case I'm going to move every single point pi over 2 to the right, but I'm not going to shift them up or down, just pi over 2 to the right. Well, remember, every one of these lines represents pi over 2. So I'm going to move every point one of these units to the right. So again, I like to move the zeros first. So that first one's going to go to here, second one's going to go to here, third one's going to go to here. Now remember, when I originally marked off my period at 2 pi, that just meant that first one stayed there. But now that I'm shifting the whole thing over, the whole thing is going to happen between 1/2 pi and 2.5 pi. But that still is only a distance of 2 pi for one full section of the sine. Okay? And then I need to move these other points over 1/2 pi, so one line, that one's going to go there, that one's going to go there. And so this piece is the final graph that represents our final answer, this sine of the quantity x minus pi over 2. Now I do want to mention something. We are only drawing one period of it. If I wanted to, I could say, hey, draw another period. And if that's the case, then that means I would take that exact same shape and I would just connect it on here at the end, right? So really this graph, and I could do the same thing, this graph could go on forever and ever in both directions, right? Let me just get this. Could go on forever and ever in both directions. So really that whole thing is the sine graph. It's just that we're only drawing one section of it, right? It's periodic, so really it goes on forever. Okay. All right. Example 2. So again, let's consider all 4 things, A, B, C, and D. So I know my amplitude is 1, because right, the number in front is 1. I know the period is, again, the B number in front of the x right here is 1, so 2 pi over 1. In this case, we're going to say the horizontal shift is 3 pi over 2. And because it's a plus, we're going to say to the left. And again, there's no number at the end, so that means there's no vertical shift. Okay, so first I'm going to mark off the amplitude and period. Well, the period is 2 pi. There's 1 pi and 2 pi. Okay, so I'm going to start off with one whole section happening between 0 and 2 pi. This is cosine. So I start and end at my maximum points, which is 1. Halfway down at -1, halfway at 0. And this is my basic cosine graph. Right? Notice I'm still curving my graph through. I'm not having it stop at those endpoints. Okay? Now I'm going to bring in this horizontal shift. So I'm going to move every single point 3 pi over 2 to the left. Well, remember, each of the lines on my graph is a half pi, and I need to move it over 3 halves. So I'm going to move all of these over 3 lines. So this first one is going to move one to here. The last one is going to move to here. And this one at the bottom, 1, 2, 3, is going to move to here. So I've moved all, let me just kind of mark which ones. I've moved this one over, I moved this one over, and I moved this one over. Okay, and so now I need to bring in those middle points. So if this one comes 3 lines to the left, 1, 2, 3, it's here. And if this one comes 3 lines to the left, 1, 2, 3, it's going to be right here. Okay, so if everything is moved to the left, now my final graph is right there. And again, that's just one period. I could just keep extending this, but all you have to draw is the one period of it. Okay? All right. Let's take this to the next level. Here comes the fun. Let's put everything in. Okay. So it's definitely going to be helpful to kind of label all the different things. All right. So remember, A tells me the amplitude. So my amplitude is 3. B tells me the period. So my period is 2 pi over, notice the B number is 2. So over 2. So the period is pi. Remember, C is the horizontal shift. And that's the C. Remember, here's my A, B, C, D. So the horizontal shift is 2 pi. And because it's a minus, it's going to be to the right. And then my vertical shift is 1 unit up. And just like I've been doing before, A and B I'm going to put in one graph. Notice I'm color coding. And then I'm going to bring in C and D. I'm going to bring both of those in the second graph. I think if you try and do more than 2 graphs, it just gets too cluttered and it's more confusing. But I definitely want you to take 2 graphs to build up to the final graph. Okay. So first I mark off my period at pi. So here's pi. Right, from 0 to pi. This is cosine. So cosine starts and ends at whatever my amplitude is. So start and end at 3. Halfway, I'm at -3. Halfway between each of those, I'm at 0. And that quickly, I can bring in 1 period of cosine. Okay, so now I'm going to take every point and I'm going to move it 2 pi to the right. So let me think, 2 pi to the right. Remember, every line is a half a pi. So 2 pi is going to be 4 lines. So 4 lines to the right. I'm just going to put this here so I can kind of have that in my brain. So 4 lines to the right. And at the same time, I'm going to go 1 unit up. Okay, so let me just show you. I'm going to take this point to start. Okay, if I move that 4 lines to the right, 1, 2, 3, 4, and 1 up, it's going to go right there. Okay, so I went 2 pi to the right and up 1. All right, now I'm going to take that ending point. I'm going to take this one. All right, I'm going to move it 4 lines to the right, 1, 2, 3, 4, and at the same time, I'm going to move it 1 unit up. And notice that those 2 points are only 1 pi apart from each other, beginning and end, because the period is 1 pi. So the whole graph has to happen in that distance of 1 pi. Okay. So now I'm going to come down here to this minimum point, 4 to the right, 1, 2, 3, 4, and 1 up. Okay, now I'm going to bring this one. So right now it's in the middle. Okay, so the middle would be 1, 2, 3, 4 to the right, and 1 up. And then this one's going to go 4 to the right, so 1, 2, 3, 4, and 1 up. So I've moved every point 2 pi to the right and 1 unit up, so my ending graph is going to be right there. And again, since I have them color coded and you can tell from the left which color is which, you don't need to label. But I want to make sure you understand, it's the pink one that represents the final graph. The blue one was just a preliminary to get to the pink one. Okay, and again, not that you have to draw this, but I want to be clear. Remember, that's just one period of this graph. Because this graph is considered periodic, that means that same piece, if I can get it there, that same piece, can't get it to match up perfectly, sorry. There we go. would keep going, right? And if I wanted to, I could put another one on. That same section would keep going. I could go to the right, or I could extend it out to the left. But do you see it looks like, oh right, how'd that one get moved down? But do you see it looks like that same piece just keeps duplicating itself. And again, I'm not saying that you have to draw all of them. I just want you to know that this keeps going forever to the left and forever to the right. So I'll just put on there what your final graph is going to look like. Okay, let's do one last one here. So let's see. In this case, my amplitude, all right, my M's are getting a little lazy here, sorry. My amplitude is 2. We don't say the amplitude is -2. We just say the amplitude is 2. But I am going to write here just to help me remember that it flips over. That's just for my own sake to help me remember. Okay. The period is 2 pi over b, but notice b is 2/3. And remember how I told you the easy way I think to simplify is to think of this as a fraction. So I'm going to think of it as 2 pi over 1 over a fraction. So to simplify, the outer would be 6 pi over the inner, which comes out to be 3 pi. I just think that's the easiest way to divide by a fraction. Okay. Remember the c is the horizontal shift, and that's going to be pi to the, because it's a plus, it's going to be to the left. And then the vertical shift brings your d number, and that's going to be 2 units down. Okay, so I'll put the amplitude and period in my first graph. So again, every line is a half pi, so there's 1 pi, 2 pi, so that's going to be my 3 pi. I'm going to mark it off. I just think it's easier if I kind of mark this dashed line. All right, this is cosine. Cosine starts and ends at that max or min point. Because it's flipped, it's going to start and end at -2. Okay, and then halfway is where it's up at +2. And then halfway between each of those, I'm at 0. So that would be halfway, and that would be halfway. So my cosine graph, which brings in the amplitude and period, it's going to be that one. And now I need to move every single point pi to the left. So that's going to be like 2 lines, right? Because every line is a half pi. So 2 to the left and 2 down. So I like to take the beginning and end. So 2 to the left and 2 down. Then I'll take that last point, 2 to the left and 2 down. Then I'm going to go to the middle one, 2 to the left and 2 down. Okay. And then I'm going to take the 0, so 2 to the left, 1, 2, and 2 down. And then this one, 2 to the left, 1, 2, and 2 down. Okay, so there's my cosine graph that's been moved over and down. Notice, even when I move them, you can see all 5 of my points. And I don't make them be just little tiny pencil marks where when you draw the graph, you can't see the points anymore, right? The points are what's going to save you, because more than likely, your graph is not going to be perfect. And so that way your points are in the right place. That's going to save you as far as getting full credit. Okay? So the homework, the 7.5 homework, basically it has everything that you can do to a sine and cosine graph.